We're at OSC 2016 in Anaheim, California. This is our SR4 and TDEC display. This station is actually designed to demonstrate a couple of key measurements that are important for the SR4. That's one of the short-range Ethernet specifications that rolled out last year. It's an optical specification, and it's over multi-mode fiber. It's designed for data centers and short-reach applications. It has some unique challenges, and we want to discuss how the tech solution works very effectively to solve these problems. We're using an ADC15 in this station here to actually work as a receiver for the multi-mode signal. This signal has a few impairments on it. The biggest challenge with multi-mode signals in SR4 is the signal level. It can actually be quite low. You need a very sensitive receiver in order to make this work in conjunction with the clock recovery. This station is actually using a CRTP option, which is a clock recovery trigger pickoff feature of the ADC15. And you can see that in this case, we're bringing a fiber in, we split it 1090. 90% of the signal is going into the main optical receiver, and this is what we use for analysis and renders the eye diagram that you see on screen. The 10% signal actually comes into a clock recovery trigger pickoff path. The signal is amplified. It comes out in a differential electric signal. This electric signal is actually fed down to the clock recovery. The clock recovery recovers the clock. It's a 25.78 gig signal, and then it sends the recovered clock off to the trigger of the sampling scope and the phase reference as well. To illustrate this, I'll just take the clock recovery signal and remove it, and you can see that we lose lock. We reinsert the clock signal, and we regain full lock on the signal. This is really unique in the test space right now. The test and measurement tool providers struggle with sensitivity, having enough to be able to do clock recovery and analysis at the same time. The Tek solution is the only instrument combination that can actually do the analysis and the clock recovery in one monolithic module. Related to supporting the SR4 specification, not just in terms of optical receivers and instrument capabilities, we have a turnkey software package. This is our SR4 measurement package that runs on the sampling scope. The SR4 measurement system also requires some measurement automation. Most notably, there's a new measurement called TDEC, which is transmitter dispersion eye closure measurement, that requires some strategic placement histograms as it cycles through a optical receiver of different bandwidths. We automate the setting of bandwidth in an optical receiver, in C15. We also automate the placement of the histograms, so we can actually go through and do a final calculation. You can see in these partial results, these screenshots that are taken here, the histogram placements are basically 4 quadrants of the eye diagram, taken at a high bandwidth and a low bandwidth setting, and it basically calculates the dispersion and the eye quality measurements in the optical signal. This package not only does TDEC, but it does all the other measurements as well. Everything from average power to extinction ratio to OMA, and we put it into one compact report that people can use to actually summarize and characterize their parts.